Hi, everyone. Welcome to another episode of Coffee and Codeless with me, Gary Hoberman. I've got my coffee and we are through the technical difficulties. So AI can't help this right now, which is interesting, but there were some technical challenges here. So apologize for starting late for those just tuning in, but we're going to make up for it here. So with me, I have the pleasure of Dave, and this is funny. I am not going to say your last name because I can't roll R's, Dave, but can you
Oh,
please
you
do
want
your
me to say my
intro for the
last
audience?
name? So you want me to
I
say
want
it
you
with the rolling R's?
with the rolling R's, please. You got to do it.
Ferrucci. How's that? Ferrucci.
Holy, yeah. See, my seventh grade Spanish, I could never do that. I think that's why I was like, I did it for 4 years, so I could read subway signs in New York, but that's about it.
There you go.
But Dave, it's a pleasure having you here. So most people that when they think of AI, they think this is a brand new thing. And I think I mentioned in a previous show that about 30 years ago, actually 1993, I tried to predict off-track bet racing using a neural net, failed miserably, and gave up AI at that point. I was like, this is not going to work. And the reality is, Dave, it sounds like you've started around probably right same time a little before. You never gave up, so you have to. Let's start with your AI journey and story if you can, and of course where you are now, and let's go back.
Yeah,
We need the wavy lines.
I've recently been asked, in a round table of a bunch of people, when have you started your AI journey? And people are like, well, last year. And so I've been at this for 30 years, and I still think I'm at the beginning. So that's the way I look at it.
I love it. I love it. And so, Dave, you're CEO and founder with a company called Elemental Cognition, which we have to both thank Google for bringing us together. And Google Cloud had seen both companies were both partnering there, and they said the two of you have to talk
Yeah.
and move forward. So let's tell the audience a little bit about Elemental Cognition, and then let's walk backwards from there and say, like, how did you get there? Let's the journey up to this point.
Yeah, so elemental cognition is really about solving tough problems for the enterprise and doing that leveraging both symbolic reasoning techniques, so complex, for example, constraint solvers that can solve a broad class of problems with mathematical precision, reliability, and transparency. But then, of course, we include the LLMs as a bridge to natural language, both on the back end, using LLMs, large language models, to help us acquire knowledge from the business, from all the business documentation that you've written, to work with the business to formalize that knowledge, turn it from language into really knowledge. But then that knowledge is still in natural language and can immediately drive intelligent applications. And these applications now are solving problems interactively, collaboratively, but they're solving it with mathematically precise reasoning. So we're turning that language into formal structures that can be reasoned about by general purpose solvers. And then we're using LLMs again on the front end to communicate with the user, communicate with the end user or the agent or the operator or whatever. So you kind of get the best of both worlds. You get that fluency of language with the precision, reliability, and transparency of that formal, symbolic reasoning engine.
Just and for myself, what I did was David set me up with a sandbox so I could actually learn and play and see how this works. And what I would describe it is there's all the excitement about AI and imprecision, and you hear hallucinations and inaccuracies, and like but then you think about what it means to apply in businesses, and most businesses will want 100% or as close to 100% as they could get as accuracy. And what you did with elemental cognition is you're striving to say 100% is here, it's real, it's a reasoning engine. And the way you actually define the logic, and you call it cogent, I believe is the language that you've
Yeah.
created. It's a English terminology to describe what I would describe as the schema, the rules, the constraints, all the things that make up someone to say, why do they do something or not? How do they come to a conclusion? And it's very interesting. And the bridge to LLMs is populating that faster and with sources other than just maybe typing, which is amazing, and just
Right.
bringing in lots of information to create it.
Well, that's
That's
right. So
so.
yeah, sorry. I didn't mean to interrupt.
No. That's am I right on that? Because
No,
that was what I kind of saw.
yeah, no, I think that's exactly right. I mean, I'll just add that, when we think about generally about computer systems and about AI and about language, right? Because LLMs are interesting because what they do, for better and for worse, is they conflate language, logic, and knowledge into this big probabilistic model of, of describing how people use language. And so, but when we get into the enterprise, there's good reason why we have to formalize our understanding, because we can't tolerate probabilistic hallucinations or errors. We go through significant lengths to codify that business logic so that we can have the precision, the reliability, and the transparency we need. So now what we do at Elemental Cognition is we say, you know what, we know how to solve a broad class of problems with a general algorithm, but it's very hard to use that general algorithm. So now with Gen AI, with LLMs, we can bridge. We could take your business knowledge, have a conversation with you, help you formalize and understand it in an unambiguous way. And then that drives that general purpose reasoner. And then we can talk to it on the front end again with large language models. And so you're kind of getting that best of both worlds, realizing that we shouldn't really expect linguistic prediction to give us the accuracy, reliability, the mathematical precision and computations that we expect to operate and automate an enterprise. So there's just a difference between informational queries and computation and problem solving.
I love it. And Dave, the way I think through it is, I grew up in regulated markets. I mean, since 1994 in Wall Street, trading systems and wealth management, and everything from the compliance and SEC regulations to OCC when TARP came around. And the reality is, most financial institutions that I manage teams, we defined a document specifying how we operate. Like, here's how we underwrite a loan. Here's how we underwrite life insurance, and here's how we underwrite P&C insurance. And some of those are state filed in 50 states, and some of those are national, but some of those are different countries and rules. The reality is, when you look back and say, hey, we're defining the constraints, we're defining our rules, and then a human being's executing against that, called an underwriter, called loan officer, called, whatever you want to name, you want to give as a consultant, they're simply following a rule set that's been defined, and then the regulators are saying, how well do you follow that rule set? That's the reality. If I was going to summarize financial services and what's been holding back a lot of the banks and capital markets, it's that concept, which is kind of, it's what the best we could do today. And Gen AI is not going to help that, because what Gen AI can't do today is repeatability, traceability, and like, hey, let me show you why we came to that conclusion.
Well, and even and even for the complex aspects of that, like, when you look at, in other words, the same platform, just to give you a sense of breadth and where precision and computation really play an important role, is even in like complex deal structuring, where you really have to comply and operate over a collection of mathematical constraints, optimizing for different things to achieve that. Well, you could describe that in natural language. You need the precision and the optimization to balance all those multiple objectives. You're going to get both. You're going to get the reasoning, you're going to get the computation, solving the linear constraints or the finite domain constraints, all from interacting with the system in language. But that same capability of doing interactive constraint solving, it's not just about optimization. It's about diagnosis, it's about planning, it's about replanning. But that same system, we have a customer who came and said, I design kitchens and I have all this cabinetry, right? But there are all sorts of architectural and regulatory requirements around it. So here's a document that lays out what those requirements are. We put it into our system and worked with our system, has a conversation with you and ends up formalizing it. Now they load up all their cabinetry and they have an expert designer where they say, I want to move the refrigerator here or there, and we'll relay out the kitchen with minimal, and this is the key, with mathematically minimal perturbation to the prior choices, but still actually fitting that refrigerator in and making the minor adjustments necessary to do that. And this happens automatically with just giving you not how to do it, not how to do the planning. You don't have to describe the how. You just describe what needs to be true about any solution, basically the business requirements and specs. And more often than not, business analysts have already written those documents.
makes total like the kitchen analogy, I guess, because all of us have gone through the nightmares of moving that
Yeah,
refrigerator around and trying to place it. So your engine would basically say refrigerator width, height, depth, power supply, here's
back
where it
and
needs
forth
to be.
up from the
But more
database, right?
back everything from the database. And by the way, here are the available cabinet widths, 18 inches, 24
Correct.
inches, 36 inches,
Correct.
and just come up with here's the wall. And let's just plan out what actually makes most
Yeah,
sense. And by the way,
here's now wall. So it'll build you a plan, and then you say, you know what? I really don't want the refrigerator over there. Can I put the refrigerator over here? What needs to change? Right. And I don't want you to change that. I want the minimal set of changes to move that refrigerator. Give me a new kitchen.
I love it.
Now
I
you say,
love
I
it.
want to move the
Instead,
oven over. And it says, I
yeah.
can move the oven over, but there's no way I can do it, right? Without, if you want minimal changes, without reducing the landing by 6 inches, which violates, typical architectural constraints. So you sure you want to do that? Right. And so, and this is done by just telling me, the dimensions of the things and what sort of the basic geometric requirement constraints are, right? We basically get that from a set of documents. And so that's amazing because you have this complex, collaborative, interactive problem solver and by the way, the reasoner, the problem solver doesn't change. You just give it a different document, give it a different spec. That never changes from application to application.
The analogies I've seen, like, and the demos I've played with, everything from scheduling hospital staff and nurses, and whether it's how many shifts and nights versus shipping yards and controlling like routes, and as well as like for those of us who travel a lot, like you and I do, like what's the best way to go from here to here and here if we can't travel on a Tuesday and only travel on Thursdays, but on Thursdays it's got to be only to the west, and on Tuesdays you could go east. And like you could basically define all the constraints you have, and it would basically come up with here's your schedule. Would you like to book the ticket? Would you like that's
or
the
or we can't do it. Here, you've given me your preferences. Here are the like smallest number of changes you can make to achieve this. Do you like it? Do you not like it? Again, it does all that sort of planning, which is kind of cool. And the other thing to mention though is that humans actually do not find these sorts of things easy to do. And they may tell you they're optimal, but they're actually not optimal. And this is why, when you're modeling this, and all you have to say is like, here's what needs to be true for any valid solution. Every time you hit a case, the system's going to figure out how to navigate that case. In the travel and logistics one we built, this is 10 to the 34th possibilities, right? So it's enormous. But as you're specifying what you want, it navigates that efficiently and is always building a plan and adapting that plan as you say, you know what, I don't want to do this, and it comes back and says, well, if you really want to minimize your layovers, then you're going to have to move, this 5 days in Germany over here. Is that what you want to do or not? Or do you want to do it, or do you want to trade that off? You don't have to tell the system how to do that. It knows how to do that once you specify the constraints.
So what I love best when Google made the intro was I have been looking for the AI partner that could do one thing that's been missing for years and years, because AI is not new. And when I was MetLife CIO, we tried to deploy AI for predictable analytics and even next best action, which always becomes itself just causes the next best action based on history and past, which doesn't make sense. And the reality was the regulators. The regulators basically would say, you can't show me repeatability. You can't demonstrate that what logic was used. How did you come up with a decision? Now, the reality is asking a human why they underwrote or approved a loan or approved a claim or rejected a claim, it's an investigation, an interview, which is inaccurate and you can't look back. So with Uncork and our role in AI, what we see our role is very clear. We're the only technology in the world that could show you the true traceability and lineage of your application in execution from the beginning of the transaction down through the storage. The AI model becomes the only variable left that you can't see into. And everything else is clean and locked down in our time machine. EC basically completes the picture because we could say, hey, EC, and we call your API and we say, we have all this data for KYC here. We've got all this data on this life insurance application or auto insurance or home insurance, and you come back and say, yeah, it should be approved, and here's kind of why. You're giving us an explanation of how you came up to it, where you sourced it, what was the reasoning, what did you find, what was the optimal plan, and we could store both the answer and the explanation together
Right.
in a vault for the first time. So you could go back in time and say, hey, when you applied for that auto insurance or home insurance, here's what the application looked like. Here's your credit score. Here was your accident history at that moment in time in the past. We stored the data correctly here. We could show you that. And by the way, the AI engine EC said we should approve the claim based on these conditions that were found.
Right. Right. These
And like
conditions.
that,
And
that's game changing. It's the first time when I saw this, Dave, that I said this could actually not just augment, because everyone's talking about AI is, going to make people superpowers and augment. This is the answer to say, how do we actually stop doing things we don't need to do anymore? Like like if it can do what we just said, you would think through many business functions and lines and say that could be 100% automated today and accurate.
right.
And and like in an ideal world, the regulators become less relevant because the technology is regulating itself based on what the regulator approved, as opposed to a human in the loop. And like then there's this whole, so that's what really excited me about like our partnership and going to market together and basically sharing that with our customers and bringing that engine, to financial services, insurance, and other industries. And it's um, KYC is an excellent use case for us, being the KYC engine for this, using you as the core. And like, so to me, that's exciting. I gotta, Dave, your background before EC. So I know you spent time at Bridgewater, but before that, you would probably be known and lots of videos out there on you with Watson. So maybe go back a little bit into the IBM Watson days, which I know there's lots of people watching who'd be like, I remember that beat Jeopardy, and I was one of the earliest technology leaders to get to go to Yorktown Heights and have Watson make me a cocktail, or at least a recipe for a very unusual cocktail, which was delicious, and see the Watson graph in action when you
Yeah.
asked a question and how it came to it. But I'd love to hear more.
Yeah. So yeah, Watson was a great project for me. I mean, I think I spent, close to 20 years at IBM, and really, the big sort of middle of my whole career was there. And I did many, many different AI projects actually, but Watson was the one that became most famous. And the way that came up was that, IBM execs were looking for the next big, project that they can do that would excite the public and so forth. And at that point, Deep Blue, the computer that had won chess, was was the last kind of big public demonstration that they had done, and they wanted to do something else. And Ken Jennings was winning. He was like in the towards the end of his like 74th game winning streak, which was unheard of, and that was making all the news. And there are a few IBM execs who were like, "Can we get a computer to like beat Ken Jennings? Like that would be like the next thing to do." And just I had been working in AI and I had been working in natural language processing. I had been working in an area called open domain factoid question answering. So basically building systems that can answer arbitrary factoid questions. And so eventually this got chopped around IBM. Long story short, I was the person who got up and said, "I think this can be done." And I was the only person who said, "I think this can be done." And anyway, I ended up taking on the project. I had a team of NLP and AI experts who had been working on a number of different things, including question answering. They all thought this was incredibly challenging. I had many contacts throughout the academia and industry who were like, "You're nuts for trying to do this." And so this was a career limiting move, as they used to say. But we took it on, and I was asked, how long do you think it would take? And at the time I was like, I don't know, I think I could do some 3 to 5 years. And I had experience doing this for some time, and it was clearly a very challenging problem at the time. But anyway, we took it on, and long story short, got it done. We went into the actual final Jeopardy game with about a 75% chance of winning. And so 25% chance of losing my job, basically. But we ended up pulling it off. It was an exciting time. I think
That must have been amazing when you were watching that. So only seven. That's what I wondered that. So there was a chance you would lose. There was a
Oh yeah.
25% chance going
Oh,
into
oh yeah.
this that.
We did many simulations. We actually did real live games. We did 125 real live games against former Jeopardy championships throughout the. Watson kind of got better and better, but even at the end, in fact, people think it was a slam dunk, but there were just the game really just turned on a couple of questions because of daily doubles. Where you could double up the amount you betted on. And so what was really cool about Watson, though, was that while when you look at the guts, deep learning wasn't even a big thing yet. We were using machine learning before really deep learning was popular and well developed. We engineered many features. We had many models that we used in succession. Anyway, it was very interesting the way we did it. But ultimately, we did, interestingly, generate many possible answers for every question. And then for each one, we went and gathered supporting and refuting evidence. And then we scored that evidence and then combined all those scores using machine learning. And we combined it many different ways and then ranked the various methods. But one of the really cool things about it was that we had to compute a confidence score. And the confidence score had to be accurate. It had to be a probability, basically. So in other words, if you took all the questions and Watson said it was 75% sure that it was right, it got 75% of those correct. And that was important because if you buzzed in and got the wrong answer, you lost. There was a negative. You lost money, and also you could look really stupid. So IBM was worried about the brand and worried obviously about winning. So not only did we have to generate an answer for each question in less than 3 seconds, like 2.5 seconds or something, but we also had to compute an accurate confidence to decide whether or not we wanted to try to buzz in.
That's fascinating. That must have been. I can only imagine when you won and you were watching this, and then that must have been a monumental moment. That must have been like,
oh my gosh!
that was.
Like I said, we didn't know, what was going to happen, and we watched it live. It was pre-recorded, like a month before it was aired, and so there was a private viewing of the live game. And everybody was sworn to secrecy. Like they couldn't tell anybody what had happened because it wasn't going to air for another month. That was incredibly tense. In fact, it was a 2-game series, and it wasn't until the last 10 questions. I mean, if you understood the rules of Jeopardy, it wasn't until the last 10 or so questions, 8 or 10 questions that were on the board that we clinched the win.
That's amazing. That is okay. Wow. And there was no vector databases. The technology didn't exist that exists today.
And by the way, it was completely self-contained. It was air gapped. It was not connected to the internet.
Oh wow! So everything was trained in knowledge and loaded in and everything.
Correct.
So
in fact, Watson never went to disk.
It never went to disk. Everything was RAM. Okay.
You built a giant index in memory of we pre-analyzed with all our NLP all the content that we could use, which a big part of the project was even statistically figuring out what content was even the right thing to load up, because we had ultimately it was limited. We had 15 terabytes of RAM. And
15 terabytes of RAM. Wow. That's amazing.
And by the way, we would still we missed an entire column of questions because Watson was too slow. We couldn't compute the confidence in time, and we just couldn't buzz in.
It's kind of amazing. It's I love the story. I love that you raised your hand as being like, yeah, we got this. Let's do this. And I it's here's to the crazy ones, right? Like Steve Jobs says, right? I truly believe that. So why not? Like, what do you got to lose?
Well, I mean, more than that, like we have been doing research and question answering for some time. The field had stagnated at about even much simpler questions than Jeopardy questions. It had stagnated at about 35% accuracy, terrible confidence prediction. And I was, my whole passion for my whole life was AI. And so I was like, as a research scientist, how do I pass up the opportunity to get a significant effort funded to see what was possible here?
I love it. I like it. So that's wow. Wow. And that's I would have done something similar to you, Dave. I think I would have been like, hey, of course we could do this. Why not? Let's just that's yeah,
Well, that's why
we've
that's why
built
that's
like
why we get along. That's why we get along, Gary. I just have to
it's
get you to
exactly
move.
right.
I
It's
just have to get you to
yeah.
move to a low carb diet, and then we're all set.
For those listening, our lunch conversation the other day, I thought I was healthy. You can see the Peloton behind me. I don't miss a day, or I'm in the park riding my bike, and I try to have salads as much as I can, but like I cannot give up the bread. Like that's the and Dave is all about the glucose limiting, right? So it's all about the so I'll take a glass of wine and I'll bike, for it. Why not? But I think it's working well for you. That's good. But it's crazy. Like I guess AI will be directing our diets pretty soon automatically and looking at us and saying what we could do. Your reasoning engine, I know what elemental cognition would tell me I should eat or not eat. Like it's exactly opposite of what I do based on all data we have. Don't eat the bread. Put down the donut. Don't. It's
It all
awesome.
depends. Actually, it all depends what the objective function you put it as.
That's true. I guess you could say enjoy food or like live a long
It's a
time.
lesson for life. Make sure you know what your objective function is.
Make sure I love it. I love it. So Dave, like just what's your favorite books? What's your like let's go through a few things. So tell me what do you read for fun and what do you think listeners should actually read or listen to, even
Well, I mean,
podcasts?
early in my career, one of the inspiring books that I read was Understanding Computers and Cognition by Terry Winograd and Fernando Flores. And that was sort of a really interesting book for me about artificial intelligence, language, and cognition. And it was inspiring for me at the time. And I've been in the field for so long and watched it evolve. It's been incredibly exciting. I think most recently, the one book that is so influential is Think Fast, Think Slow by Dan Kahneman. And again, I think for similar reasons, just because I think one of the things, and like the books I read for fun are philosophy books. I love quantum mechanics. I love deeply reflecting on the universe and life and existence and cognition. These are things that kind of like really get me going. But I think that there's another role AI plays and I think will continue to play, which is really to make us deeply reflect on what's important to us. Intelligence is a tool. We are more than that. We are about consciousness. We're about human values. We're about moving and evolving as a species about what's important about our existence and about each other. And I think what AI starts to do is help us appreciate, the depth and humanity, and really not measure ourselves on can we do this task faster than a machine or something like that. So it's about the experience. It's about caring, understanding how to manage ourselves, in our lives. So, and I just think if we treat AI as a way to understand ourselves and how to manage ourselves, I think that it's an important reflection we should be getting out of all this.
I like it. The Thinking Fast, Thinking Slow is one of my favorite books. That is absolutely like the question is, will there be an AI fight or flight response, or will there be a slow response and how to activate it and the
I
speed
think
of
there
eating
already is.
something?
I mean, I think we see that. I think we see exactly that. And I think there's a couple of things. I mean, I think first of all, just being aware of human cognitive biases and the relationship between our biases and the AI. Is the AI, are we using AI to further or amplify our biases? Or are we using AI to eliminate our biases? Do we even know what our biases are? And AI can be used to do either. Right now, sadly, I think it's reflecting and amplifying our biases as opposed to helping us get around our biases. But I think we have to be deliberate about helping you get around our biases. And when you think about system 1 and system 2 in Thinking Fast and Thinking Slow, AI architectures today, when they're doing predictive analysis, purely data-driven analysis, that's like thinking fast. I'm taking my prior experience and I'm just extrapolating it. I could be horribly wrong. If my prior experience is wrong, I could be horribly wrong. If my prior experience is biased, I can be horribly biased. when you're doing the thing. Thinking slow means, what am I doing? What is my decision-making process? And subjecting it to your values, to your, to understanding the implications, to articulating the actual decision-making process. And that's the thinking slow. And
I love it.
We do both. You and I, we do both.
Yes. So why win a machine?
And
Also,
I
like
think
that's
I think good A architectures, not only should they do both, but they should be aware of when they're using the data-driven, potentially biased extrapolation, and when they're doing transparent decision logic.
I love it. That's, Dave, we had fun the other day, and Richard, he's in charge of a whole sales engineering team, and he's been having fun. So he built for me a chatbot where it's OpenAI versus Vertex, and it's just how many rounds do you want to go, where they both get past the same question, but then the second one gets past the response first, and you watch this, and it is fun. I mean, you ask the question, "Are you human?" And you watch them kind of go at it with each other, and it's like, "No, I'm not a human artificial." And the next one goes, "Well, it's really nice to meet you, artificial machine." We did one for fun where my CTO yesterday and I sat down and we said, "You're writing a new writing a new mystery, and it's act one of the play, and it's a crime scene set in New York City, and you are the actor. Go." and whatever it was, Vertex said, "Hey, I'm here," and then OpenAI responded with an entirely new character. It was actually fascinating, but I think we're going to be for a while in this scheme of seeing which models are best for which purposes. You're very unique in what you created because it's a reasoning engine. It is directly saying algo is 100% accuracy, and and a model that's explainable and repeatable, and that's very unique in everything I've seen to date. And to me, that means it's more applicable in enterprise. That's where enterprise comes into play, which is why, again, we're super excited by what you're doing.
But no, that's right, and we're excited too. And we're not losing the fluency of the language, right? Because we know that humans like to think, they like to talk, they like to communicate with language. It's where they're most creative. How do we take that language and then formalize it so we can get that precision and reliability and transparency with mathematical?
Exactly.
So, yep, that's the idea. Anyway, this has been great.
Awesome. So Dave, thank you again. I think you and I are on stage in another week or two at an event here in New York City. I think we have coming up, or we're going to be there soon. So I get to see you in person again, and I will be the one eating the donuts, the crackers, the bread, but and smiling, but that's okay. And but yes, Dave, again, thank you again for joining us here on Coffee and Codeless, and I look forward to seeing everyone next time as well. Thank you, Dave. Thanks for joining.
Yeah, take care.
Thanks, everyone. Take care. Thanks. Bye-bye.